want you to stop and think about something for a moment. Food waste is a climate giant. So we actually have more emissions from wasted food than we have from aviation, global aviation combined together. And I think that's, if we think about that problem, that's not really a software problem, is it? It's a very complex problem. It's a problem of biology, it's a problem of chemistry, it's a problem of complex logistics. And it used to be the case that the physical world is just too complicated to be able to optimize until now. So I brought this little friend of mine here. We can call it the AI nose. I can show you what it looks like. So this is a PCB board with lots of different sensors on it. These sensors, they capture organic volatile compounds, so they can basically smell. And when we can put this into the physical world, when we can take these sensors and put them into the physical world, we can do something very dramatic. So this is just a small piece of the puzzle, but it's a part of a monumental challenge to put intelligence into the physical world. And I think, and I'm going to argue in this presentation, that the digital revolution with AI was only the warm-up, and that we're going to see some fantastic things coming out of intelligence when we start applying it in the physical world. So in order to solve things like food waste, it's not enough to use code or interfaces or anything like that. We need to start optimizing the physical world, and we need to tackle the largest challenges that we have, which are in the physical environment. So you probably follow the news. When I started talking about AI and when I started building AI in the end of the 90s, it was pretty easy to catch up with everything that was written about AI in Sweden. So if I had a lecture or something like that, then and they would mention an article, then I would have read that article. So it was possible to see everything that was written about AI, at least in the mainstream media. Today we have headlines about AI in every day in every newspaper. And it's impossible to keep up with it. But if we think about what these headlines are about, they are usually about generative AI, right? About generating text, about generating images, videos, creating chatbots, or producing code. And here in Sweden, we are actually proud pioneers. We have been incredibly successful with these digital AI startups. And there's talk now of Silicon Valhalla, and it's not just something that we talk about here in Stockholm. It's something that is being talked about also in Silicon Valley, in Germany. It's been in newspapers all over the world. So why are they talking about Silicon Valhalla? It's because we've had some incredible unicorns recently. Of course, we had Spotify, we had Klarna, but just in the last few months, we've had Lovable. So Lovable is a vibe coding AI software where you can go in and write in free text and then generate web applications or pretty complex software actually that you can build with it without writing a single line of code. And this is not just the fastest growing startup in Stockholm ever. It's not the fastest growing startup in Europe ever. It is the fastest growing startup in the world ever. And it's from here in Stockholm. So that's quite incredible. We also have Sana Labs. They have an amazing agent platform and also a platform for teaching and for bringing out knowledge in an organization. Very impressive, also unicorn, so they have a valuation that is above $1 billion. And then we have Legora that can produce agreements, draft agreements, help us understand legal text. Incredible. And I have not been as excited as I am about AI since I built my first neural network in C++ in 1998. It's quite incredible. A lot of things are happening here now. But I also think we have to think about something here that is a bit of a paradox. So we're using this. This is the most transformational, the most important technology that we've ever created as humans. And we're using it for what? We're using it to solve some digital issues, to help us with admin, things like that. Doesn't sound right. You know, we should be using this to tackle the biggest challenges that humanity is facing. So what are these challenges? Well, of course, climate change is one of these huge challenges. This is not about information. This is about the physical change in the atmosphere, the physical change in our oceans. Another challenge is energy, the physical flow of electrons in our grids. And of course, the whole area of manufacturing. So in manufacturing, we are moving atoms in our factories. We're assembling atoms in our factories. And while I'm very proud of the digital startups that we have in Stockholm and in the Nordics, I think we need to urgently focus on these physical issues. So thinking about digital intelligence is solving matters of information. But the biggest problems, as I mentioned, climate, energy, efficiency, they are solved by optimizing matter. And there's a huge difference here in the data when it comes to the digital world, if you compare that to the data that you have in the physical world. So the data in the digital world, it's quite abundant. If you want to train a chatbot or something like that, you can just go out and scrape the whole internet. Everything that everyone in here has written and everyone else in the world, it's up there on the internet and you can scrape it, bring it down. And start training on it. And it's the same thing with images. Like you're uploading images here. There's a photographer here. I'm sure some of his images are going to end up on the internet. And for sure, they're going to be used to train AI. So it's very accessible. Scraped text, scraped images. But with physical data, it's proprietary. It is tied into legacy systems. It's often siloed into different factories, even separate production lines. And it's connected to legacy machines. It's unique to each facility. It's much more difficult to access this data. So it's much harder to gather, and it's much harder to integrate the intelligence into this world. There's also a lack of standards. When you take a picture with a camera, there's a few different formats that you can upload that picture in. But when it comes to sensor data, there's an abundance of different ways of handling this data. But it's also, I would argue, infinitely more valuable. It is at the heartbeat of the value creation that is happening in our physical industries. So I'd like to propose that we try to create a physical Silicon Valhalla, that we take this now from the digital world and get inspired by digital Silicon Valhalla and do something more in the physical world. Use AI in our factories, in our grids, in our supply chains, and our ports and our hospitals, as we heard earlier today. We need to be inspired and do something with this. And I'm going to take 4 examples that I've been part of, 4 projects that I've been working in at Savantic AI Lab where I am, where AI touches atoms. So the first is nuclear power. So the nuclear industry is very challenging. It is a critical and unforgiving thing to work with. You are not allowed to make mistakes when you're working with nuclear. The consequences become very serious. And the efficiency in this industry is not just about profits. That's not what we're talking about here. We're talking about something that is connected to global safety, that is connected to sustainability, and that is powering a lot of other industries. So very critical infrastructure of our society. And at the core of all nuclear reactors, there is a very slow and manual and cumbersome process of fuel management. So basically, when you are putting in the fuel rods into the reactor core, you want to optimize this core so that you get a maximum of energy out of this. But there are many other things that you need to consider. So for example, when you pull out one rod, move it and put it into a new place in the reactor core, it costs about 200,000 Swedish crowns to do that movement. You need to stop the reactor, you need to go in with the machine to do this in a dangerous environment. So we've been working together with Vattenfall and the Forsmark plant to try to develop something that can make this process more efficient and improve on it. So the way it normally works in nuclear power plants is you have a bunch of specialized mathematicians and physicists who work, do a lot of calculations when they're configuring the core in the reactor. And this work typically takes 4 to 8 weeks to complete. It's a manual thing that you need to do, and then you can reconfigure the reactor. So Forsmark wanted to challenge this. And together we've been working on something called Loadmaster. And as you can see here, it's not the most modern user interface because this is a project that has been going on for 15 years in order to perfect this. This is a huge investment, but it's also something that is paying itself back with pretty nice ROI numbers, which I'm going to come to as well. So basically, we want to optimize 3 things here. We want to optimize the energy output. We want to minimize the number of movements of fuel rods that we're doing because they are impacting the time that we keep the reactor stopped. And we want to reduce the amount of new fuel, uranium, that we are using in the reactor. Also, a side effect of using less uranium is that you don't have to store it for as many years. Still, you know, quite a lot of years, a lot longer than we're going to live in here. But yeah, it's also a good thing. And some of the effects that we've had by applying machine learning and physics-informed machine learning models in this field is that we've gone from this 4 to 8 week cycle to be able to configure the core in just a single day. And we can look at many more different configurations of the core also than you could do when you're doing this manually. Also, the reduction in fuel cost for just this one power plant is between 12 and 14 million Swedish crowns per year. And when you're using less fuel, then you need to handle less fuel also in the end when you're storing this for 100,000 years or however long. And finally, and most importantly, we've been working together to increase the efficiency of the reactor. So the reactor is now operating and producing 15% more electricity, which is quite incredible. You know how much it costs to build a nuclear power plant and how many years it takes. Well, you can ask Finland. They've been working on some of those, and it's been taking quite some time. And this solution is already transcending its origin also, because now we're working together with Westinghouse, which is a global consulting firm within the nuclear industry, and they are taking this to many, many new power plants. So it's very exciting. So this is just one example. The next example I want to talk about is in the steel industry. So in the steel industry, it's also a very challenging environment. It's very warm, it's dirty, but in Sweden, we're able to export not just any steel, the world's hardest steel. And we've been able to do this. I mean, China is investing a lot. They're trying to compete. They're working very hard on this. So we're never going to have the cheapest steel in Sweden, but we might have the most sustainable steel, and we can have the hardest steel. And basically, you have these huge ovens that are driven by gas. And of course, you want to reduce the gas amount because it's costly and it has a large environmental impact. So we've been working on this. So in the beginning, we just wanted to be able to predict how much gas are we going to use. But then quickly, we were starting to move deeper into this and understanding that, okay, we can actually optimize to lower the amount of gas that we're using. And we can get the perfect heat curve, so we even can get even better steel. And this has developed then into a real-time control system for these steel ovens. And we kept going from there as well, started looking into the rolling mill. So here you see a digital twin of the rolling mill. It started as a simulator where you could try and mill the steel. But then when they were working on it, they saw, okay, it's much better. It's actually, I do better steel in the simulator than I can do in the real mill. So I want to have this. I want to have the same information that I have in the simulator. I want to have that available also when I'm working with the real steel. So then we started building a plexiglass where you're projecting laser onto it so that you can get an augmented reality experience when you're working as an operator in the mill, and you get the same information that you have in the simulator, and that way you can work with it. And a nice side effect here is actually it was really hard to recruit operators into this area. But when you have a cool gadget like this to show on the big fairs, then all the kids are lining up. They want to try this. They want to grab the joysticks and they want to try to run the steel mill. So this is also a fantastic side effect. Maybe not what they were imagining in the beginning. But to build this sort of solution, you need to have thermodynamic modeling, you need machine learning, you need optimization, you need real-time control design, integration with PLCs and so on. It's very complex. But this digital twin can predict and control, and it can help us to produce even better steel. And the customer here, they have even started to turn this into a product and selling it now internationally and implementing it on other steel plants. And just to give you an idea of the climate impact here, so one single oven in the steel industry, when we installed this AI-driven software into it, it reduced the carbon footprint with an equivalent to 100 cars that are on all the time. So, I mean, this can make a big difference. We can make a big difference in the physical world that we can only dream of in the digital world. And also the material waste. I keep looking at industry after industry, and we've had so cheap electricity here in Sweden. So we've been able to waste it. We've been able to waste a lot of energy. It hasn't cost that much. There has been no real economic impact on the company doing that. We cannot afford to do that anymore. AI is also going to consume a lot more energy. So we need this energy. We need it to electrify. And therefore, we can apply AI to reduce waste, both physical waste and also waste of energy. The third example, which I'm extra happy to present here, because I know there's a lot of friends here from Xylem, and we've been working together with Xylem. We've also worked with some other companies, and the infrastructure in water is extremely important also for the climate. So 7% of global energy consumption comes from handling water. So it's both producing fresh water, distributing it, and also taking care of wastewater and treating the wastewater. And about 30% of the fresh water is actually lost if you look globally through leaks in the pipes. So there's a lot of room for improvement here. So we've been building this AI system with cameras and microphones that can monitor what's going on in the pump station to optimize the energy usage in the station, to use the right pumps, to understand what is the hardware that is installed in this particular pump station, and to reduce the risk of sewage overflow, which is not very nice if it happens in your basement, but it also has a lot of climate impact when it's happening, or environmental impact when it's happening out in a field somewhere. And detect the fat buildup and start to understand what's going on here, how much is it building up, and when do we need to do something. We've also worked with another company that has developed bacteria that can eat fat. And when you put this bacteria into a station like this, they continue to evolve, right? That's the amazing thing about bacteria. And when you have cameras in every grease separator or pump station, you're essentially turning every grease separator and pump station into an R&D lab, because the evolution is happening there. And you can see, okay, now these bacteria in this particular pump station are eating fat much more efficient. We go out there, we sample it, and now we have a new product. It was developed there, out in some of the harshest environments that bacteria can live in, I guess. They're probably happy eating fat. That's what they like. We, though, like to eat avocados, right? We like that much more than eating fat. globally 1/3 of all food produced becomes food waste. So fruit and vegetables is a top category here. For us in here, people of the EU, we have about 130 kilos of food waste per person and year. So this is a lot of waste, and a lot of it is, by the way, wasted just because of appearances, because we don't look like how the banana or the cucumber looks, which I hope that we are not part of that, right? We eat the banana even if it looks a little bit bad, but it still can be very tasty. And globally, as I mentioned, 10% of greenhouse gas emissions come from food industry and from agriculture, and 24% of all the water usage is from agriculture. And the EU has actually been looking at initiatives trying to reduce food waste, and they've seen that for the companies working with this, they have an average return on investment of 14 times the money. So it's actually very profitable to invest in reducing food waste. So we come back to this AI nose here. So this AI nose can smell the gases from the fruits when they are getting ripe and when they're eventually getting moldy. So we can tell how long time the fruit is actually going to be possible to sell in the store. And we can reject them when they're already coming into the warehouse, especially when it comes to mold and mold spores. You want to reject things before they get into the warehouse, because then it can spread and it can have a large effect on other things. And if you've been trying to buy raspberries, for example, it's pretty common that you get moldy raspberries. But there are other sensors, of course. We have, for example, multispectral sensors. If you have a multispectral camera, if you can look in the IR field, you can actually look underneath the skin of the avocado and see if it's damaged without having to cut it open and look at it. So there's a lot of interesting things happening here. And with these examples, what I wanted to really show you here is that physical AI works. You can apply this in the physical world. You can have superhuman capabilities already in AI. We're talking about super intelligence, but the sensors are already much better than the sensors that we have as humans. We cannot see through the avocado, but if we give the right sensors to the AI, it can. So the question is then, with this incredible impact, why are we not seeing this in every steel mill, in every reactor, in every pump station, every grocery chain? Well, I think physical Silicon Valhalla needs to win a battle on two fronts in order to be able to scale this. So the first is that there's a big difference, when you're trying to implement things in the physical world. So in the digital world, things move at the speed of light, right? But in the physical world, we're more like operating with the inertia of mass. So it's much more difficult to do this. And if you want to go from implementing something in one reactor to 100 physical reactors that are all a bit different, then that's a huge engineering and integration task. But I'd like to claim that this is not a bug. This is a feature. This is something that we can actually use to our advantage. The digital world could never dream of that type of long-term first mover advantage that you can get. Because if you actually implemented this, it's going to last for quite a while. And if you look in the digital world, you remember when DeepSeek came out, the stock markets were shaking. You can build a chatbot now and release it in an hour globally. And the prompts have already leaked from Lovable, from Cursor, from all these other companies. You can download them online. Anyone who has the capital can start building a competitor. But if you've done all this integration work to fully integrate in a steel mill, in the legacy sensors, in the power grid, it takes years to build, to debug, to certify. But it is also our moat. That is how we protect industry in Sweden and in Europe. And it is a long-term edge. So we just need to think about this a little bit differently. The second front that we need to win on is the mind shift. So this is our final test of ambition. In physical Silicon Valhalla, we need to embrace disruption. Lovable, Legora, Sana Labs, all these companies, they immediately scale globally. They have that from the outset. They are digital natives. They are going to take over the world. We need to think in a similar way. What I see in industry oftentimes is that you do a pilot project, and then you prove something, and then you see that the technology works, and then nothing happens. Nothing. And it can take years before you start taking it into production. That's not okay anymore. That's something we need to stop doing. We need to raise the bar now, and we need to shift the mindset and have the same level of ambition that we have in the digital version of Silicon Valhalla. And this is also critically important for Sweden, but also for Europe. So why should we lead this charge? Well, we are the original industrial powerhouse in Europe. We've never been the most cheapest, as I mentioned. We've been the most innovative. And while China and the US is dominating in the world of digital AI, I think physical AI can be Europe's ticket to a continued industrial existence. And it's very important because that's what we live from. And it's also good to think about where are we heading now? Where are we going? So here you can see what's happening to growth of the economy. There's a new geopolitical order happening. It's clear that the US and China is dominating and that we cannot afford to stand still. The saying goes that the US innovates and that China copies and then Europe regulates. I mean, that's pretty sad, right? And I'm not saying it's a bad thing. I really want us to work with ethical AI here in Europe. I'm actually very positive to the legislation that has come out of the EU with the AI Act. I think it's a great legislation. I don't think it's problematic. But we must also provide solutions. We cannot just be the judges, you know. If we have a soccer team of Americans playing against a soccer team of Chinese, and then we have a European referee. Come on, we can do better than that. We want to have our own team, right? So we need to provide these solutions, and we need to invest heavily, and we need to be ruthless about applying this technology in our industry. And this is a window of opportunity. If we don't do this now, it's going to be very, very dangerous for the European economy. We need to be best at optimizing matter. And the best thing is that there's already a lot of things happening here. So if we look at Marcus Wallenberg and Jensen Huang meeting in Linköping, they're talking about Spherical AI, the new company that will provide these incredible compute to Swedish industry companies. And just to take a few quotes here, so Marcus Wallenberg said that investing in cutting-edge AI infrastructure is a crucial step towards accelerating the development and adoption of AI in Swedish industry. And Jensen Huang says pretty much the same thing. The CEO of NVIDIA comes to Sweden and says, you know, just like electricity was, AI is the engine in the next industrial revolution. And this is a joint project, Spherical AI, together with AstraZeneca, Ericsson, Saab, SEB, and NVIDIA. And we need to see this level of ambition in every industry at scale. That's what I want to say. So going back to the start with this AI nose here. So the climate giant of food waste that we need to tackle, the smarter energy that we need, smarter infrastructure. These are the global challenges that we need to tackle. I'd like to summarize this and say that Europe has an historical mandate. We could really, with our industrial engine, become the leader in physical AI. And mastering the weight of the physical world, that can be our long-term advantage. And it can lead to an infinitely better world. And also all the regulation that we have in Europe, it doesn't really affect the physical world, does it? You know, it's GDPR. You don't need to care about that when you have sensor readings from your sensors that you're putting out. This electronic nose is not likely to be able to smell, or maybe it actually can smell who a particular individual is. But as long as it's smelling fruit, we're safe. And also, I think with the GDP growth, we need to catch up here, and this is our chance to be efficient, profitable, and to become one of the most powerful places where we apply new technology in the physical world. So now imagine Sweden in 2030. So we're leading this change. We have efficient factories. We have no food waste. We have stable energy at low costs. That's what we like, right? And we have workers who are empowered by AI because we're using AI in an ethical way. And we're investing to scale. Everything here is happening already. This is not a fantasy. It's happening, but it's happening in silos. If we can just take these solutions and bring them to the rest of the world, we can be incredibly successful. So I want to leave you with this question. When are we going to see the first physical AI unicorn in Sweden? And what role are you going to play in making that happen? So I think the future is not just intelligent. I think it is industrial, it is sustainable, and it is deeply human in its purpose. Let's build it together. Thank you.
Thank you, Marcus. Wow. I think I just found a sort of direction that I've been lacking when it comes to what role Sweden can play. I actually wanted to ask Dr. Gao about sort of the difference between Singapore and Sweden and what we need to do to get in the front of developing AI, and you sort of nailed it. So thank you.
Thanks.
We have plenty of questions from the audience. Again, questions about Wi-Fi as well. Info about Wi-Fi is in the event app, in the general information. So just look it up.
Isn't it funny how we talk about Wi-Fi still?
Yeah,
you know,
especially after Dr. Gao's presentation. Yeah. It's all about 5G, guys and girls. Let's see where to begin. We have both like highly technical questions, but also questions that I know that you like, speaking about the human factors in this. So let's start there. How do we change the mindset of corporations and their leadership when they're widely known for their conservatism? And do you agree with the question? Are they known for that?
Yeah, I think to a certain extent, industry is conservative. You want to see that things work. And if you are going to stop a production line to do an upgrade or something like that, it's a big decision. I think actually when the economy is not doing so well, that's when we should be investing in that, when we're not running at 100% capacity. So there's an opportunity to do that. But I also think that there's a lot of ambition. I mean, if we look in the steel industry, for example, I meet a lot of people. They don't care about the hype. They don't care about generative AI, all these things. They only care about if it works or not. And I think that is the right mindset. So there's a lot of ambitious people out there, but usually also there's a power structure. Like the power is very close to the floor. So if you're operating in one line, that's where you take the decision on if you want to upgrade something or put AI in there. But AI actually benefits from taking a bit more centralized approach, and that's something that is challenging for us in Sweden, I think, and it's challenging in the physical industry.
I was going to ask you that, like what type of setup? You've been involved in over 200 different projects, and I get that question a lot. Like, what type of setup? Do we need a center of excellence, or do we need somebody just organizing everything that we do with AI? So what type of setup do you see is actually working?
I think you have to work a bit differently depending on the technology. So when it comes to generative AI and making that work, I think it's very good to have this kind of bottom-up strategy where you let all the flowers bloom and you see what kind of catches on, and then you can work to implement it. But when you're working with industrial AI, it's not enough to look at one single oven and then have the person who is responsible for that oven work with that in a small silo. That's never going to scale. So you have to take a much larger outlook on it and see like how can we centralize the data? How can we work in a similar way with all our ovens at the same time? And if we do a pilot project, how can we scale that to the entire industry? And I think that's what we don't really have today.
Yeah. So we have a question here. You spoke a lot about sort of the industry, But how about the society? How do we bring it back to people? I would argue that many of the projects that you mentioned bring it back to the people too, but to improve healthcare, to improve elderly care, to reduce our working hours. And I think this is a great opportunity to bring in one of the cases that Savantic cases that I wrote about in my book.
Fantastic book, by the way.
No.
Buy her book, it's great.
But we're not here to talk about the book, but let's talk about the project. SL, so the public transportation in Stockholm, and actually preventing suicides.
Yes.
Tell us about that project.
Yeah, so we've been working with cameras looking at the tracks. So the beginning of this project was to create an autonomous red line. And there were many different parts of that project, but one of the parts was how do we see if somebody falls onto the track or is trying to commit suicide? How can we stop that from happening? And for various reasons connected to the signaling system in the subway, it was never turned into an autonomous system. But this camera track continued. And we proved with cameras that we can detect when people are about to commit suicide and when people are falling down on the tracks. And in this study that we did on 2 stations, we found that it's about 10 times more people on the tracks than we knew about. But the challenge was that we're a consulting firm, so we're 35 people. But SL, they did not want to buy from a consulting firm. They want to do a tender and buy this from some product company, but there were no product companies out there that could provide this product. So then we worked with the market to do the whole tender of this. And how do you tender this process? How do you create the test data so that you can evaluate it? And eventually the market was able to answer. And some companies that were used to do security cameras, for example, could adapt their technology and create something. And the last time I checked, it had saved 22 lives. So I think that's just incredible.
Yeah, definitely worth. Even one life is
Absolutely.
worth saving. Yes. Thank you for sharing that. And speaking of that, one question is also, how do you decide which projects to work on, which industry you want to look into? Obviously, you are approached by potential clients, but how do you focus?
We're in a sort of a luxury position, I would say, because there's a lot of companies approaching us. So we get to pick and choose a bit. And we're doing this using something that we call meaningful AI. So meaningful AI for us, it has 3 components. So the first is that it should be innovative. It should be something that doesn't already exist as a product out there, because otherwise buy the product, use the product. The second thing is that we want this to have an effect on the bottom line. So I actually think it's much harder to succeed with a learning project when you're experimenting and trying to learn something. It's easier to try to create real value. So you should move your mindset into creating real value. Like how can we take care of the patients? How can we save lives? What can we do? Then it's actually easier to succeed, because then you get all the stakeholders to come on board. So that's the second thing, that we wanted to have a bottom line effect. And usually that is related to profits, because that's how you get people to engage. And then the third thing is we wanted to have some positive effect for humanity in some way. It could be related to climate, it could be related to human-centric. Yeah? So these are the 3 criteria that we look for when we pick which clients we would like to work with.
And is this a model that you would recommend to people? Because I know in most audiences, people are at a stage where they're looking for ways or models to identify where they can start their AI journey, like the first.
Yeah, and I also think another very simple rule of thumb that you can look at. First, you can look at how easy is it to implement, and how much, and that also is often related to how much data you have. So if you have a lot of data available, and then if you have a large impact, that's a good project to start with. Start with those. And also the other thing is to look at the center of your business, what you're doing, the most critical things, and try to implement it there. So if you're looking at the HR process of your company, it might be important, but it's probably not your core business unless you're a recruiting company. Then I think you can just wait. There's going to be a lot of software vendors who will come with different solutions to you, and you can implement those. But when it comes to your core, you need to have the best data and you need to have the best AI solutions, and that's where I think you should focus and build something.
I can tell that we're running over time. I just want to ask one last question. What should people look for? Because I can see in the stats and in the research that one critical factor in succeeding with your AI projects, and not a lot of people succeed, 95% or so actually fail with their AI pilots. So one factor is to choose the right technical partner. So my last question to you is, how do you find the right technical partner? How do you know that somebody is not just selling you sort of snake oil, but actually implements AI in great ways?
On a less serious note, you can just give me a call. But but on a more serious note, I mean, there's a lack of competence in this area, and I think we're unfortunately not using the experience that is out there. You heard from the WASP program here, 200 PhDs already have come out of this program. There is tremendous amount of talent. And we at Savantic, we have been able to attract talent also from all over the world. We're only 35 people, but we have 28 PhDs from 20 countries. They're moving to Sweden to work with this. So Sweden can really attract talent. I think Sweden is very attractive, especially for people who are looking to create a family and so on. So we have a lot of things going for Sweden. And also, I think the most important thing is to look for people with experience. And if you want to build your own AI team, make sure you have at least one person that they can look up to in this team. So don't recruit a bunch of people who come freshly out of KTH. I think they are great, but they also need to have one role model in there that can kind of stabilize the team. And also make sure that you have challenging things for them to work on. I see so many companies recruiting a bunch of junior talent and then putting them working on software development, not really using machine learning. And then after a year, they will quit because there are more interesting places to work. So that is probably the most important advice I can give.
Great advice. Thank you so much, Marcus.
Thank you so much.